Now we will solve the Laplace transform of a trigonometric functions. Our first question is find the Laplace transform of sine kt. Here kt is an angle. According to the definition of Laplace transform, we have 0 to infinity e raised to the power minus st into the function over here, that is sine kt and dt. Now just integrate this improper integral. We can solve as integration by parts. So first function as it is, make what will be the first function. We can take e raised to the power st will be the first function and sine kt will be the second function. And also you can reverse this, you can take sine kt as a first function as well, and you can take e raised to the power minus st as a second function as well. So don't worry about that. So what will you have left? First function as it is, integration of second. So it will be cos kt divided by k, and the integration of sine will be negative cos t, and this will be 0 to infinity and then minus 0 to infinity. The same answer will be shifted over here, cos kt divided by k into the differentiation of the first function, and the differentiation of the first function will be e raised to the power minus st dot minus s into dt. Now after simplification, what we have left, but before solving this integral we have to simplify this one. So keep in mind, if you insert minus infinity over here, it will become e raised to the power minus infinity, and this minus sign will be over here, cos of infinity, then minus, and this minus will become plus, so it will become e raised to the power 0 cos of 0 and divided by overall divided by k, and this minus will be plus, but this minus will be negative, so it will become 0 to infinity s over k will be out of the integral, and then we have e raised to the power minus st into cos of kt dt. E raised to the power minus infinity will be 0, and cos of infinity means the cos have range between minus 1 to 1, so it will give some answer. And if we say this answer is a, but e raised to the power negative infinity is always 0, so it will become 0. Similarly, e raised to the power 0 is 1 and cos 0 is also 1, so we have just left 1 over k from here, and then we will integrate this further in the same way as we have done before. So what we have, the first function as it is, integration of this, and the same answer will be over here, and the derivative of this function will be e raised to the power minus s t dot minus s into dt, and the bracket will be closed. And after this, what we have, You can see over here this will be 0, so we have left over here just 1 over k from there. And if we multiply this s over k into the bracket, and what we have, so minus s over k, and we have applied the limit over here as well, 0 to infinity, and after solving this particular case we have minus s over k, and if we apply e raised to the power minus infinity sine of infinity, and then minus e raised to the power 0 and sine of 0 divided by k. This is the format, and then minus 0 to, and what we have, and this minus and this minus will become a plus, and s over k is out of the integral, and we have 0 to infinity e raised to the power minus st dot sine of kt dt. And you can see here this is just become this function Laplace of sine of kt. So we can replace this overall integral by Laplace of sine kt, and but before going to solve this we will simplify 1 over k minus, this will be 0 as we have done before over here, e raised to the power negative infinity is 0, cos infinity is a some number because the cos and sine both have the range from minus 1 to 1. So in a similar case this will be 0 and this will be a, so after multiplication the answer will be 0, and sine 0 is also 0. The overall factor, this factor will be cancelled out, and what we have left, we just have left minus s over k with 0, this 0 plus and this s over k, and then we can use Laplace of sine kt according to the definition, according to the given question from here. And now we will move into the next. 1 over k minus s square over k square Laplace of sine kt, and then now what we have left, we have Laplace of sine kt, which is equal to 1 over k minus s square over k square Laplace of sine kt. In this way you can easily find the Laplace transform of sine kt. Just take this one from here, Laplace of sine kt plus s square over k square Laplace of sine kt, and we have 1 over k by taking Laplace of sine kt is common. Laplace of sine kt is common, and we have 1 plus s square over k square is equal to 1 over k. By taking an LCM, Laplace of sine kt, we have k square plus s square over there, and then finally Laplace transform of sine kt will be 1 over k, this will be multiplied over here, k square over s square plus k square. So 1k will be cancelled out, and we have left, what we have left, Laplace of sine kt is k over s square plus k square. So this is our final answer in this particular case. Similarly, you can solve Laplace transform of cos of kt and you will get the answer s over s square plus k square. In the same way, you can calculate the Laplace transform of the trigonometric function of cosine cos kt. So answer will be this one.